Welcome back to Contemporary Math. We want to continue taking a look at apportionment methods today. And the first thing that we're going to look at is Hamilton's method for apportionment. So in Hamilton's method for apportionment, what we do is we consider the standard quota for each group. So we find the standard divisor, and then we consider the standard quota for each group. And once we have the standard quota for each group, we round it down to find the lower quota for each of those groups. So initially, we distribute the lower quota to all of the groups. Now, of course, that's going to give us not enough, or we will not have distributed all of the items. So what we do is we say, all right, well, let's give out the remaining items to the groups that have the largest fractional portion. So what I mean is if I'm supposed to distribute 19.5 of the items to one group, and I'm supposed to distribute 19.2 to another group, and let's say 13.7 to some other group, then what I'm going to do is I'm going to focus on the fractional portion, the 0.5, the 0.2, and 0.7, and observe that, which ones are larger than others. So 2/10 is less than 5/10, which is less than 7/10. So if I have two more of the items to distribute, they would go to the two with the largest fractional portion. So that's what we'll take a look at in Hamilton's method. Okay, so we first distribute the lower quota, and then we will likely have some left over, and we distribute the leftovers to those with the largest fractional part. All right. So for this example, we're actually looking at a slightly different situation. We're looking at nurses instead of doctors, first of all. But we have 200 nurses to apportion among 4 shifts, shifts A, B, C, and D. So the hospital decides to apportion nurses based on the average number of room calls reported during each shift, right? If there's a lot of room calls, they're going to need a lot of nurses to be able to handle those room calls. So they distribute the nurses based on room calls. So shift A receives 750 room calls in a shift. Shift B receives 980. Shift C receives 503, and shift D receives 166. Right, that's probably your overnight shift, your 11 p.m. to 7 a.m.ers, but that doesn't really matter. For those of you that know shifts, you can make speculations there. Anyway, so we want to we'll perform Hamilton's method by following these 3 rather basic steps. So we want to determine the standard divisor and the standard quota. Once we do that, then we actually go ahead and start distributing. Once we start distributing, we've officially entered Hamilton's method. Okay. So the first thing to do is to determine the standard divisor. And we can do that right here in a little bit of room that we have. So the standard divisor is given by the number in the population. So the population we're considering here is the number of room calls. Okay, there's a total of 2,400 room calls, and we're distributing a collection of nurses. So 2,400 room calls divided by 200 nurses gives us a standard divisor of 12. Excellent. Once we have that, we just need to determine each shift's standard quota. So this was part A. For part B, this will take several steps, and that's okay. 4 parts to this. So shift A, B, C, and D. So for shift A, the standard quota, right? The standard quota in each case is given by the number of people or things in the population. So a population of A is 751. divide that by the standard divisor of 12, and we get 62.583. The number of decimal places included here shouldn't matter too much, but we want to make sure that we have enough to recognize which fractional parts are the largest. So if I end up with another one that was 62.5, I'd need to know which one was larger. So 5.8. Well, what if it's also 5.8? So I went to 3. Of course, we could do many, many decimal places for this, but this should be more than sufficient. All right. Okay, so that's shift A. Shift B, the standard quota is given by the population, 980, divided by the standard divisor of 12 to get 81.666 we'll go with. So that way we can make appropriate comparisons. And then we have shift C. Their standard quota is the population, 503, divided by the standard divisor of 12. And that is equal to 41.916. And then we have shift D, and their standard quota is 166, the population, divided by the standard divisor, and that gives us 13.83. I believe the 3 is repeating, so 833. So this gives us our standard quota. Once we have the standard quota, according to Hamilton's method, we give out the lower quota. So the initial, so for part C here, we have the initial disbursement or apportionment. It's technically not a full apportionment yet because we'll find that not all of the nurses have been allocated. So the initial disbursement is that shift A gets their lower quota, and the lower quota would be 62. Shift B gets their lower quota, which is 81. And then shift C gets their lower quota, which is 41. Right, so I'm just chopping off the fractional portion. I'm chopping off the decimal places. And shift D is going to get 13 nurses. All right, but we should notice that the total here is 62 plus 81 plus 41 plus 13 gives us 197. So 3 of the nurses have yet to be assigned a shift. So there are 3 nurses left to distribute. So there's 1 shift that's not going to get a nurse. We're not going to get 1 more nurse, that is. So in order to determine which shifts get the nurses, we simply consider which ones have the largest fractional portion. Of course, all of these would round up. So all of them are above 1/2. So I'm not simply looking at those that round up versus those that round down. I would have to consider those that have the largest portion. There are definitely examples where all of them are less than 1/2, so they would all technically round down, but they'll still get that extra nurse because they have the largest fractional portion. So I'm just comparing the decimal places here. So I can observe that shift A has the smallest fractional portion of 0.5 0.83. And then shift B has the next largest fractional portion of 0.666. And then shift D has the next largest at 0.833. And then shift C has the largest fractional portion at 0.916. So again, that's shift A, shift B, shift D, and shift C. So there are 3 nurses left to distribute. So we'll pluck off the highest 3 fractional portions. So highest, next highest, next highest. These are where the nurses will be distributed to. So these shifts will receive the additional nurse. So each one of them will receive an additional nurse. Once we do that, once we distribute the additional nurses, then the final apportionment according to Hamilton's method. Right, that's who we're working with here. Double check that, right? It's Hamilton method. Yep. Okay. Good. So the final apportionment according to Hamilton's method would be shift A did not get any additional nurse, so they stay at 62. Shift B, they get an extra nurse, so they go from 81 to 82. Shift C, they go from 41 to 42 because they get an extra nurse. And shift D, they get an extra nurse, so they go from 13 to 14. And then you should notice here, of course, that the total is exactly what we would like it to be. So let me kind of give it as a comment. The total nurses distributed here is exactly what it should be, the 200 nurses. Excellent. And that is Hamilton's method. In the next video, we'll look at Jefferson's method. So I'll see you guys back here shortly for more apportionment.